Good evening. Today I'll show you how to wrap an object with electricity or whatever you want to wrap it around with using the raycast node and the shortest edge path node. So what we need to do is delete everything, and afterwards we're going to pull out a monkey, a Cezanne monkey, and go to geometry node editor. Now I'm going to wrap it using what's called an icosphere. I'm going to wrap it using an icosphere. Let me go to mesh primitives, icosphere, and I need to first of all make sure that the icosphere is fully surrounding the mesh. I need to set this to 4 subdivisions and then go to utility, no, geometry, join geometry, and let me put the radius in here because I want to use it on multiple different objects. And I need to make sure that the icosphere is larger than the object that I want to wrap it in. So what do I need to do is, let me pull this up. Now, how am I going to wrap it around this monkey? First of all, I need to use a raycast. I'm going to geometry, raycast. Now this emits rays towards the target geometry in a direction from points of other geometries. Sorry about that. Now let me get rid of all of this, Control X, and let me go to geometry set position. Now we want to, now in order to demonstrate this raycasting, I need to put this is hit over here and the hit position over here. Now, as you can see, something is going on up here. Why is it only happening up here? That's because the ray direction is going down. The other ones aren't hitting anything. They're going down too, but they're not aren't hitting anything, so they don't appear on this Boolean value is hit, as you can see here. So thus they don't have any sort of position to change. But let me make this a bit more clear for you. Let me up it to 7. Yeah, good. Now, if I want to change this direction to, let me see, 1 on the positive x-axis, now all of the rays will be going to this toward this direction. But I don't want that. I want all of these rays to go to the towards the center of the icosphere. So how am I going to do that? It's very simple, actually. You go to attribute, capture attribute, float, vector, turn the float to vector, and go to input, normal, like this, and plug this into the ray direction. Now, as you can see, nothing's going on, nothing's happening around this icosphere. That's because the ray direction is going like this. As you can see, it's all going all the way there. So we need to reverse it. How are we going to reverse it? We're going to vector math, add. Now set it not to add. Set it either to multiply and set all of them to -1. And as you can see, our sphere is wrapped around the monkey. But if you don't want to use this -1s all over the place with this node, you can set this to scale and put -1 right here. Same thing, but a little bit more neat, as you can see here. Now let me decrease these to 4 subdivisions because they're easier on the eyes and easier on my computer. So now what do we need to do? Now we have the basis for setting the electricity on our monkey, our object. How are we going to do that? It's very simple actually. Actually, it's not very simple, but let's just say it's simple. We need to use the edge paths to curves node, and as you can see, there's an input that says next vertex index, as you can see here. Now, what the hell does that mean? I don't know. But all I know that if you want to use the shortest edge path node, you need to pair it with this edge paths to curves node. So We are going to now I'm going to explain how this works. Now the start vertex looks for the shortest path towards the end vertex, as you can see here. Now we need to specify which vertex is going to be the first vertex. So I'm going to make this a bit more a bit simple for all of you. I'm going to set this to integer and plug this into here and put this right over here. Now as you can see, it's working. It's working very well actually. Actually, I forgot to do something. I don't understand what's the need for this, but apparently you need to do this for some reason. It's related to the edge cast. Now, what you need to do is you pull out this edge vertices node, you go to vector, vector math, distance, put this one over here and this one on here, and plug this in. Now, apparently this makes it a bit more accurate, I think. A bit more correct, let's say, when it comes to calculating the edge cost and the distance towards something. That's what I think, but I'm not sure actually. If I should have this at all times when using the a shortest path node. You can actually plug in a noise texture in here. You can go to texture, noise, go to color, I guess, put color in here and mess around with it until you get some desired result like that. Let's forget about that. Let's put this in here. Let me show you the vertex that has the index 0. So we're going to curve. Remember that this outputs curves. I'm going to curve, trim curve, pull out the start, and as you can see, they're all going all the way over to here. Now, when we add 1 to this, now this is this is a vertex with the index of 1, and vice versa, just like that. It's going all over our monkey, like that. These are all the vertices of our monkey, as you can see here. Let me set this back to 0, and let me go over here. Now, let's say that we want multiple start points on our monkey. So how are we going to do that? It's very simple, but it requires a lot of node setup. It's going to be a bit more annoying than understanding the shortest edge paths and how it works, but it's very necessary for all of you to learn. Let me get rid of this. We can just plug this in here. Let's make this one something like 39. Shift D. 192. Let's set a fourth point and make this something like this. Good. Put this in here. Put this one over here. And I'm going to use a Boolean math node and set to and. Shift D. Good. And then I'm going to combine these and then combine these and then Shift D, combine these. Hmm. Oddly enough, it's not working. Should I set it to OR? Yeah, I guess I should have set it to OR. Let me see if this is going to work. Now, as you can see, it has chosen 4 different points to look for the shortest path. Now, the start vertices, when we don't define which vertices are going to be the start vertices, it's going to take all of the other vertices that are not the end vertices and trace a path from them towards these end vertices, like this. Now, let me change up these vertices a bit. Okay, looking good. Okay, I don't know what the hell I'm missing with. Okay, 4 points on our poor little monkey, like that. Okay, good, good. And just like that, our monkey has electricity flowing through it. Now, let me show you something. When you trim according to the end, you're gonna see something really odd. Let me get rid of these. Yeah, so we only have one start point. As you can see, when I get closer and closer to one, nothing seems to change, but now they all seem to retract, to get trimmed. Now, as you can see here, when I pull it up, you might notice that these curves are overlapping, which might result in issues with performance and stuff. So, how are we supposed to mitigate for that? You can turn these curves into a mesh and afterwards use okay, let me go here in order to show you. Let me go to statistics. Now, if this was a curve, these statistics won't appear. So let me mute this. They won't appear. Vertices, edges, faces, triangles. These are splines. These aren't geometry. You can call them that geometry. I'm not sure. But anyway, they don't have vertices or edges or faces or triangles, all that stuff. When I bring this back, as you can see, we have 8,484 edges. Now, how are we going to get rid of all these edges? I mean vertices. It's very easy. We go to merge by distance and put it right here. And as you can see, the amount uh, turned out to be quite less than 10% of the original amount, like this. Now, this is going to help us performance-wise, help us a lot performance-wise. Sorry about that. Had a very heavy dinner. Let me scale this up. Okay, good. Now, now this way looks like it's fixed our problems, but I want to do something else with this icosphere. I want to turn it around, transform. Let's go pick up. I wanted to turn around this. That's why I use this weird method of wrapping it around it and then finding the shortest edge paths and stuff like that. Now I wanted to wrap around this, but as you can see, it might not look very it might look pretty, but when we add a noise texture, it's going to be very chaotic. I want these curves to go flow with the noise texture. When we do this merge the that part about merging the paths and all that stuff is going to be very chaotic. I want it to go and flow with that noise texture with which we're going to offset this thing. So I'm going to get rid of this and introduce some things that you might not have learned while using Blender. We're going to delete geometry, set this to spline. Oh yeah, we set this to mesh. Yeah, let me get rid of that. Set this to spline as in curves. And we're going to utilities, Boolean math, and do this. Let me actually get that curve to mesh back. Not Boolean math, I meant the utilities random value, and the random value is going to be Boolean, just like that. And as you can see, the higher the probability of this Boolean random value, the more what's called curves are deleted. And as you can see, this also cuts short on the amount of curves we've got, which also helps our performance. But still, I don't like this method a lot. So what can I do else? So what else can I do? You can go to curve, what's called spline parameter. Go over here, pull out this length, type in compare, like that. Compare less than or equal. Where's less than? Yeah, less than. Just like that. So let's set this to 2. Now, what this is going to do, it's going to, let me increase this. Yeah, there it is. What in the hell? How tall are these curves? Actually, this isn't working as well as I expected. If you want to go with the merge points, you can. Wait a minute, let me turn this around a bit. Hmm. Actually, it looks quite nice, frankly. But still. Actually, yeah, I forgot. This is how it's supposed to work. This is how it's supposed to work. This is what it does. Now, this compares the lengths of these curves, but I see that it's deleting these point by point, not spline by spline, like the way I want it. Now, this is really odd. I don't know why it's doing that. I set this to spline, right? Not point. Wait a minute. Let me pull this way over down here. Yeah, okay. Now it's deleting point by point. Okay. This is very weird. Let's set this back to spline. Hmm. Okay. Maybe it's the distribution. Wait a minute. Let me cut this off. See what happens. Nothing different, frankly. But actually, this is the one of the many looks you can get with this if you want. Get this sort of rotating effect that looks really nice, actually. That might help too. Now, let's forget about all of this and let's get back to the part where we turn these into lightning or electricity. So what we're going to use is curve. Actually, let's me get rid of this delete geometry. I don't want it because I want to show you other things you can do with it. Let's go to curve, resample curve. Ah, crap, curve to mesh. Ah, piss off. Good. Oh yeah, that's why it wasn't working properly. Because oh no, it's working the ways. Ah yeah, forget it, I'm an idiot. Okay, let me resample these curves to 0.01. Good, that's a lot, but I don't care. Now I'm going to offset them by set position, texture, noise texture. Put it right over here, offset. Good. Do okay, actually let me do this. Now it's looking more like electricity. I'm going to vector math minus zero point 0.5, shift D, scale, scale it down a bit. Now this is looking really great actually. Really wonderful. Now this is how, and then let me pull out the, let's call the joint geometry node right here. Joint geometry, thank you. Let me grab this, shift right click, grab this, and then put this right over here. Good, good. And let's see. Now this is looking fine. If you don't like the way they're covering this, that they're all going inside and stuff like that, you can go to geometry, transform, and up the scale a bit, but not a lot. Okay, good enough. Now, what are we supposed to do with this is the following. Not 4D, looking nice, eh? Looking like electricity. If you don't want these to follow along with each other like in this predictable fashion, what you can do is set the W value to each of these curves index. You can go to attribute, capture attribute, integer, spline, and then you go to what it's called again, input index, like this and like this. Now, as you can see, they all have their own W values. So let me cut this off and explain this to you. When I set this to 3, it's different than the last one. 4, it's very different. 5, a lot more different, and stuff like that. So it keeps on the scale value, and all that stuff, but it just changes the, let's say, the seed or the offset of this. So if you want them to be a bit more chaotic and to look more like something like roots or whatever, you can use this if you want and dampen the scale to something like zero point 0.1, like this. Yeah, looks more like wires or roots or hair, frankly. And it looks kind of nice. Let me do this first. Let me get rid of this. Yeah, as you can see here, looking nice, eh? Okay, but I don't think I want that at the moment. What the hell did I do? What the hell happened? Oh yeah. Oh yeah, the scale is so small. Let me bring it back. Do something crazy like this. 7 is good, I guess. Yeah, good. Now I'm going to give the monkey its own material. It's going to be just the default materials. I'm going to material set material. Remember that this line is our monkey. And I'm going to let's go to duplicate this and go to the vertical split, shader editor, new. I'm gonna call this EL, short for electricity. And I'm going to delete this, go to shader, emission shader, all that stuff. Good. Turn this to blue. Make this really fucking bright. And when we go to rendered, wait a minute. When we go to rendered, nothing's gonna happen because I did not add a not convert into mesh, and I did not add a profile to that mesh. Curve to mesh. Curve primitives, curve circle. I don't want my computer to crash, so I'm going to set this to 3. And just like this, 0.005, 01. Actually, it worked a lot. Yeah, as you can see, it's now our little monkey is now covered with electricity, lightning, or whatever, or roots. And you can rotate them over the object like that, which it looks very nice. Now, this whole setup is just so I can get this effect. Just this effect. That's all I wanted this whole time. This just the effect of the lightning going around, rotating, moving along the surface of the object. That's why we're here, as you can see. Now this is very convoluted, you might tell yourself, but when you go over it chronologically, step by step, it all makes lots of sense, as you can see here. Now, this is a very, not very simple tutorial. Actually, let me set up the light for this. Let me go to Shift A and 3-point lights. Now, this might look weird to you. Let me go here and add some bloom to make it a bit more pretty. Yeah, looking nice, Mr. Monkey. Let me select this camera, grab on the local Z. Good. Stuff like that. Go here, turn all of this black, and turn this off. Now, this monkey is getting electrified, which is very nice actually. Now, this is the end of this tutorial. Actually, it's not the end of this tutorial. I want to show you something else that you can do with this electricity thingy. If you don't want it to look like that, if you want just bouncing electricity, dancing around the monkey that isn't growing like roots around the monkey. So what I'm going to do is very complicated. I'm going to delete this and delete this. Okay, keep these. Keep the material because I don't want to put it back again. And I'm going to put this back in here because why not? And I'm going to math modulo. Where's modulo? Here's modulo. And shove this right into here. Shove it right into here, Blender. Come on. Set this to 2. Now, what this does, if you've ever done coding, programming, or stuff like that, is modulus. What it does is that it brings out the remainder of the division. Now, this might not be very clear what the remainder of division to you is, but when you divide 3 by 2, the remainder is 1. When you divide 4 by 2, the remainder is 0 and stuff like that. And 5, 1, 6, 0, 7, 1. So you get a 50-50 chance. 50-50. So you split the vertices between being endpoints and start points, as you can see here. But nothing is happening for some reason. Now, why is that? Okay. Should I get rid of this? Oh my God. Start vertices, end vertices, end vertex, modulo index. What's going on here? Relax, going to relax. This is really weird. This used to work. This actually worked. It's not that it used to work. Next end vertex over here, distance. Who gives a shit about this? Modulo. This is really weird. This should return 1 for all of them. I don't understand what's going on. Is there something wrong with my setup? I'm going to compare integer equal and vertex. Okay, this is, I don't understand. Where's my stuff? Where's my Suzanne? Okay, go over here. Oh my God, I'm such a fucking idiot. I'm such an idiot. The whole thing was turned off up here, so the result was that the curves don't appear when you do that. Now, what the hell is this is going on around here? Oh my God, I'm getting confused. Okay, get rid of these. They're distracting me. Get rid of the camera too. I don't care. Now, where are my curves, Blender? Select Suzanne again. This is supposed to work. This is set to 7. Okay, now it's working. Ah, crap. I'm such an idiot. Go to math, modulo. You understand what it does, I think. Okay, go here. And as you can see, half of the vertices are now end vertices, the other half are just start vertices. So start vertex looks for end vertex, start vertex looks for end vertex. So they are equally distributed to be what is called to be curves all around the thingy, as you can see here. Now, what we can do is if you want to have another look for your electricity on your object, you can go to curve. This is going to be very complicated. We need to get these normals after the set position. Shift D, go over here. Yeah, good. Let me plug this all the way over to here too. Good. Now, okay, you might not understand what I'm doing here, but just bear with me. We're going to set the spline type to Bezier, set the handle types on the left and the right to vector, and then we're going to set the position of the handles according to the normals. Now, if you dealt with Bezier curves in like normal Bezier curves, not in geometry nodes like in Blender, you know what the handle does. So without further ado, I'm gonna pull out these normal informations and put them right here. Now, as you can see, they're all going away from the monkey. Now, what we can do is we can pull out this scale node and set it to something small like zero point 0.2. Now, this is looking really nice. We can rotate it and all that stuff like that. And we can turn it into crazy electricity by going to curve, resample curve, let's set it to 20, and afterwards we can go to geometry, set position, offset, texture, noise, or noise, fuck off, texture, noise, texture, color, vector, vector math, minus zero point 0.5. Why did I delete my noise texture setup? I keep doing this noise texture setup each fucking video. I should find a way to make it a bit more faster. Now, as you can see, this is becoming more and more like electricity around an object. You can mess around with the how those are away from the monkey and how they are displaced around this. Good. Now I'm going to what's called, yeah, curve, curve to mesh, curve primitives, curve circle. Pull it over here. Set this to 3, 0.0, 0.001. Looking good. Set the material to EL and EL. Geometry, join geometry. Uh, my God Almighty. Go to geometry, transform, up the scale a bit, because why not? Actually, let's go to rendered mode, see what this looks like. Let me go back to this 3-point light. Okay, good enough. Looking good, Mr. Monkey. Turn these off. And there you go. Electricity surrounding your beloved object. Hash frame over 250 multiplied by tau, so it rotates 360 degrees. Okay, looking good. Now, this is the end of the tutorial. Hopefully, this is the end of the tutorial. Let's hope that I haven't forgotten anything else. Now, this is how to wrap your object around with electricity or whatever you want. And it's actually complicated, but it allows you to understand some very weird concepts in Blender, like raycast and the shortest edge paths and all that stuff. Now, this tutorial is very messy, I know that, but I always do my tutorials in one take because I'm too lazy to install DaVinci Resolve. Now, let's hope that the next video is going to be a lot more shorter than my previous ones, and because then I would have installed DaVinci Resolve. And let's hope I quit being a lazy motherfucker and install it. Now, I wish you all happy blending, okay? And go take care. Bye.